So now we will solve question number 11 from the year May 2020, Physics Unit 4. This question is from magnetic field. In the question they have said, the photograph shows a model electric motor. In this motor they have said a coil of wire is mounted between the two magnets. So this is the wire of which is mounted between the two magnets north and south. When there is a current in the coil, it rotates. So this is a current carrying conductor. This is a current carrying wire. The wire through which the current flows. They have said the diagram shows the position of the coil viewed from one end, when it is an angle of 20 degree to the horizontal, which is at angle of 20 degree to the horizontal. The current is into the page at X and out of the page at Y. There are 10 turns on the coil. This is a really important thing, that there are 10 turns on the coil. And the current in the coil is 6.9 ampere. They have said determine the resultant moment about P. So this is our pivot and the magnetic forces acting on the coil. They have given out the length, width, current, number of turns, and the magnetic flux density. So let's go and solve this question. We all know the formula of moment, which is moment is equal to force into distance. So we have to find out the force right now. So the force will be we all know the formula of force. Force is equal to VIL sin theta. Here it will be, let's do the sin theta part later on. Just focus on BIL into N, because there are number of turns given. They have given us the number of turns. BIL is for just one turn. As they have given 10 turns, we have to multiply this BIL into 10. So the magnetic flux density, they have given us the magnetic flux density, which is 0.07. Into the current 6.9 into the length, which is this, the length of the coil. Don't take the width of the coil. We have been asked to find the length of the coil. So it will be 0.05. It is given in centimeter, which needs to be turned into meter, into the number of turns of the coil. This formula BIL is only for one turn. And as they have given the number of turns of the coil, we have to use this 10. If they have never give, if they didn't give us the number of turns of the coil, then we would have never used 10. So the answer of this situation will be 0.242 Newton. So we have got 2 marks out of this 4 marks. So let's do the later part of the math, which will be, they have asked us to find out the moment. So we are done with finding out the force. Now we have to find out the moment, which requires the distance. And another thing that needs to be seen is that they have said us to find out the resultant momentum, not only the momentum. We have to find out the resultant momentum. So let's go into the diagram and let's look at this. If you look more closely into the diagram, they have said that at X it is into the page and at Y it is out of the page. If you use Fleming's left hand rule, then you will be able to find out that this is upward and here it is downward. Sorry, the drawing was it was downward and it was upward. As we all see, the distance is like this, and the formula of momentum says the force must be perpendicular to the distance, but this force is not perpendicular. So the perpendicular distance will be this, which will be F 20. This is the 20 which will be here as well. We all know that this angle and this angle is always similar. So as this is within the angle, it will be f cos 20. We have already found the f, and now we have to find out the cos 20. Okay. And let's find out the distance part. We all know the whole length of the coil is 7. So up to this point P, which is our pivot, it will be 3.5. And this will be another 3.5. No, actually it is overall 3.5. So this will be 3.5 by 2. And this will be another 3.5 by 2. So let's find out here, which will be moment is equals to f cos 20 into 0.035 divided by 2, and this f is going to be this f is going to be 0.242. Cos 20 to 0.35 divided by 2. Okay, so another thing that I want to show you guys is that they said resultant momentum about P of the magnetic force acting on the coil. Up to now we have found out only this part. We have to also find out this part as well. So we have to multiply this by 2. We have just found out half of them. We have to find out the forces, the moment of the resultant momentum acting on P. So P, we have found out this portion of the P. We haven't found out this portion yet. So we have to multiply it. We have to double it. So let's go and double it is equal to 2. The answer will be can you please find out the answer and let me know what is the answer? Tasnova. Tasnova, what is the answer?
7.96 into 10 to the power minus 3.
This is our answer. We have divided these two because it was perpendicular this way.